Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good morning. Alright, so we will continue our class with chapter 2. Right, before I proceed, let's check the teaching plan first. So this week is week number 4. So this is week number 4. So we are going to learn new chapter 2, second order ordinary differential equation. So today is 17 April. So based on our teaching plan for today, I want to cover the first topic, which is method of solution for homogeneous second order differential equation. Then for next week, we will have a midterm break from 24 to 28. So this is a midterm break, week 5. So week 5 we have midterm break, and then we will continue on week 6. So there will be also one quiz 2, 15% also. And in this chapter 2, we also will have some question in the midterm test. As you can see, we have application of first order and second order in midterm test. So there will be an application for first order and second order. Let's see what else we will cover for this chapter. So I think that's all. So we have homogeneous equation, which is second order differential equation. Homogeneous equation is quite different from the first order differential equation. Then we have non-homogeneous. We cover two parts: method of undetermined coefficient and variation of parameter. And then we have Cauchy-Euler equation, and lastly application. Let's see the chapter number 2. So the general form of a second order linear ordinary differential equation is given as this equation. So in this equation, as you can see, we have a second order of ordinary differential equation. And then don't forget, we also have first order differential equation with some function 1. And then for the coefficient of second order, we have ax. Coefficient of first order, we have by. Coefficient of y is cx, and some function fx. So this is equation of second order linear differential equation. So a, b, and c are function. If a, b, and c are constant, then we may have a homogeneous and non-homogeneous equation. So now we want to see the first part, second order linear differential equation with constant coefficient. So our function ax, bx, and cx, now let's treat this one as a constant. Constant is a number. So this is the chart where we have a second order linear differential equation. So for second order with constant coefficient, we will look at the equation where fx equal to 0. So if we have fx equal to 0, then we call this equation as homogeneous equation. Let's write our equation first. So we have our equation ax d square y over dx square plus dx dy dx plus subfunction cxy equal to fx. Now, if our ax, bx, and cx are constant, then we may write this one as a u squared y dx squared plus b dy over dx plus cy equal to fx. So this one belongs to this group where our constant coefficient, our function abc is a constant coefficient. Now let's say our function fx, this function fx equal to 0. So we call that equation as homogeneous equation. If our function fx not equal to 0, then we call this one as non-homogeneous equation. So I hope you do not confuse the terms of homogeneous with the first order. So in first order, we also have a term for homogeneous equation. So do not confuse with the first order differential equation. So here homogeneous means fx equal to 0, and non-homogeneous means our function fx not equal to 0. So if our function is non-homogeneous, we have fx not equal to 0, then there are two methods to solve this equation. First method is called method of undetermined coefficient, and second method is variations of parameter. Just now I have told you that if our function ax, bx, cx is a constant. Now how about our function fx, dx, and cx are not coefficient, which is it is a variable coefficient. So if we have that kind of function, then we have one method to solve this equation or this ODE. We call that method Cauchy-Euler method. Okay, so for today, I would like to focus on the first method, which is our second order linear with constant coefficient, which is homogeneous equation. So the homogeneous equation means fx equal to 0. Alright, so the general form of homogeneous equation is given by equation 3.3. So this is our general form. So we have a d squared y over dx squared plus b dy over dx plus cy equal to 0. And don't forget, because this is a linear ODE or linear differential equation, so you must have the function or the variable y, which is y to the power, the highest power must be equal to 1 in order to call this is a linear equation. So this is the general form where a, b, and c are constant. Constant means numbers. If we have the equation 3.3, in general, the solution is y equal to exponent mx, where m is a constant. So first thing first, if we have the homogeneous equation, where we have the equation 3.3, we have a d squared y over dx squared plus b dy over dx plus cy equal to 0. In general, the solution is y equal to, where m is a constant. So this is our solution. Actually, this is the simplest version of y equal to exponent mx. So our job is to find the m. What is our m value? So to find the m, what we need to do is first let's take y equal to e and x as a solution. So we want to treat this solution, or we want to substitute into our differential equation. So in our differential equation, we have second order, so we have second order, and we also have first order. So what we need to do is take the solution y equal to exponent mx, and then you must differentiate first time. So differentiate y dy over dx, so you will get m exponent mx. And then because we have a second order, so differentiate one more time to get d squared y over dx squared. So we will get m squared exponent mx. Now, what we need to do now is substitute back this dy dx and d squared y over dx squared into the original equation. So substitute back the equation. So we have a times dy dx, so a times m square exponent mx plus b times m exponent mx plus cy. So which is y equal to exponent x. So you now you get this equation. And then
Sir,
yep.
sorry kacau. Saya rasa suara Sir perlahan sangat.
Okay, okay. Ni okay tak? Jelas tak? Boleh kan? Macam ni okay
Lagi jelas daripada tadi.
Okay. Okay, so
Okey, okey.
after you have differentiate y, so you get m exponent mx and m squared exponent mx. So substitute back into the equation 3.3. So you get this equation. Because we have a common term here, exponent mx here, also here exponent mx. So what you need to do is you can factor exponent mx. Now here we have am squared plus bm plus c. Okay, since exponent cannot be 0, so if you plot the exponent graph, the exponent function never touch 0. So since exponent mx cannot be 0, in order for this equation to be true, so we have exponent times am squared plus bm plus c equal to 0. So in order this equation to be 0, this one cannot be 0. So which one must be 0? Here. So am squared plus bm plus c must equal to 0. So am squared plus bm plus c equal to 0. This equation we call a characteristic equation. Remember, our job is we want to find what is m. So here from the second order equation, we have transformed this equation into characteristic equation. So we call this one as a characteristic equation. So we want to find the value of m. This is quadratic equation. So if you remember the quadratic equation, for a quadratic equation, you may have three kinds of root. You have three kinds of root for m. In order for this equation to be 0, we may have three kinds of value for m. Alternatively, this equation also you can find by substituting the following substitution into the equation. So what you need to do is for d squared y over dx square, you just substitute with m square. Dy over dx, you just substitute with m. And y, you just substitute with 1. And then you substitute into the equation. So here is a m squared plus b m plus c times 1 equal to c. So now you have transformed this one into the characteristic equation, or sometimes we call auxiliary equation. Okay, so the solution for this quadratic equation, there are three possible solutions. Because we have quadratic equation, we have m squared, am squared plus bm plus c. So because the highest power of m is 2, you must have maybe a, a real and distinct root. The first case is you have a real and distinct root. That means you have different m. You may have m1 or m2. Different value of m. You have two value for m. So the general solution will be y equal to a exponent m1x plus b exponent m2x. This is the first case. So how you know the first case? The first case is we take from the quadratic equation b squared minus 4ac greater than 0. So if this is the case, then you may have two value of m, real and distinct. There are two different values. So the general solution y equal to a m1x plus b exponent m2x. A and b are constant of integration. Okay, the second case is m1 equal to m2. So you now have two values for m, which is m1 and m2, where these two values are equal. So there is only one value for m, m1 equal to m2, which is equal to m. So the general solution, if you use this equation, the general solution will be a exponent mx plus b exponent mx, bx exponent mx. And then we can factor exponent mx, so now you will have a plus bx times exponent mx. So this is the case of real and equal root, where we have the quadratic equation b squared minus 4ac equal to 0. The third case will be where you will have a complex root. So this complex roots will happen if we have b squared minus 4ac less than 0. So if b squared minus 4ac less than 0, then the values of m will have alpha plus beta I plus minus beta I. So you have two values for m. So m1 equal to alpha plus beta I, m2 equal to alpha minus beta I, which is beta I is a complex solution. So in order to write the general solution, we will use this form. This is called Euler's equation. So you write the solution as y equal to exponent alpha x. So this one will be exponent alpha x multiply a cos beta x plus b sin beta x. So in this solution, there is no the I. We don't have any I. We just transform this equation by using Euler's equation. So you write the equation y equal to exponent alpha x multiply a cos beta x plus b sin beta x. Alright, let's see some example. So we have d squared y over dx squared minus dy over dx minus 6y. So let's check this equation. So we have a second order linear differential equation with constant coefficient. So we have a constant coefficient, which is this is 1, 1, and 6. And we also have a linear where the power of y is 1 and then the function fx equal to 0. So in order to solve this one, this is called homogeneous equation. So in order to solve this one, first you must transform this equation into characteristic equation. Okay, so to transform characteristic equation, so take this one as m squared. So we have first coefficient 1, so we have m squared minus, so this one will be m minus 6y, y substitute with 1, so m squared minus m minus 6 equal to 0. So now you have a characteristic equation where the characteristic equation is in second order quadratic equation. So by using a calculator, or you want to factorize this one, or any methods you want, if you can use calculator, then you may proceed with calculator. If you want to factorize, you also can factorize. So if I factor this one, I will have m plus 2 multiply m minus 3. This one equal to 0. So we have two values of m. So m1 equal to minus 2 and m2 equal to 3. So this is the first case. So the first case is we have real and distinct rule. Real and distinct roots. So the solution will be y equal to constant a exponent m1. m1 is minus 2x plus b exponent 3x m2 x. So this is our solution. No need to solve for b squared minus 4ac. No need to write this one. This is just to know which type of our possible solution. So this is the first solution where the case is real and distinct roots. So hence this is our solution. Y equal to a exponent minus 2x plus b exponent 3x. Alright, let's see the second example. Alright, so this is a second example. We have a IVP, initial value problem. So we have when x equal to 0, y equal to 4. When x equal to 0, y prime equal to minus 2. So there are two values for IVP. We need two values to compute the constant of integration a and b. So that's why we have two values of IVP. Okay, first transform this equation into characteristic equation. Okay, so first we have m squared plus 3m minus 10 equal to 0. Then by using your calculator, or maybe you want to factorize this one, so we have m plus 5 multiply m minus 2. So the solution will be m1 equal to minus 5, m2 equal to positive 2. Therefore, we have real and distinct root. So we have two roots, two values of m. Hence, the solution will be a exponent minus 5x plus b, another constant b, exponent 2x. Then remember we have initial values where our initial values given y0 equal to 4, y prime 0 equal to minus 2. Since we have y prime, that means we must find the y prime first from the solution. So y prime equal to a exponent minus 5x multiply minus 5 plus b exponent 2x multiply 2. So we have minus 5a exponent minus 5x plus 2b exponent 2x. Alright, substitute our initial value into this equation. So we have y0 equal to 4. So 4 equal to a exponent minus 5 times 0 plus b exponent times 2 times 0. So we have 4a exponent 0 is 1, a plus b. So this is our first equation. Second equation, y prime 0 equal to minus 2. So we have minus 2 equal to, substitute in this equation in y prime. So minus 2 equal to minus 5a exponent minus 5 times 0 plus 2b exponent 2 times 0. So we have minus 2 equal to minus 5a plus 2b. So this will be our second equation. So we have a simultaneous equation. We want to solve for a and b. So you can use your calculator. If you have a new calculator, you can just substitute the values, the function by using the simultaneous equation. Substitute to find a and b. If you don't have that calculator, you must do manually lah. So let's do manually. So from equation number 1, so we have 4 equal to a plus b. So let's take b equal to 4 minus a. So substitute b into equation number 2. So we have minus 2 equal to minus 5a plus 2 times b. b is 4 minus a. So minus 2 equal to minus 5a plus 8 minus 2a. So we have minus 10 equal to minus 7a. Hence a equal to 10 over 7. So b equal to 4 minus a. So 4 minus 10 over 7. So this is equal to, so 4 over 1 times 7 times 7, 28 minus 10 over 7. So this is 18 over 7. So A is 10 over 7, B is 18 over 7, hence the particular solution will be 10 over 7 exponent, which one? So this one, substitute. A is 10 over 7, B is 18 over 7. Exponent minus 5x plus 18 over 7 exponent 2x. Alright, so this is our particular solution for the example number 2. If you are given initial values, substitute into equation to find the constant of integration A and B. So you get the particular solution. And let's try this one. Find the general solution for the given differential equation. D squared y over dx squared minus 8 dy dx plus 16y equal to 0. So no initial values problem. So no initial values problem mean our solution will be in the term of constant integration A and B. Alright, first let's transform this one by using characteristic equation. So we have m squared minus 8m plus 16. Then solve the quadratic equation. So we have m minus 4 multiplied m minus 4. So we have only one, m equal to 4, positive 4. So this is second case where we have a real and equal root. So we have values. We only have one value for m equal to 4. Hence, our solution will be y equal to a exponent 4x plus bx exponent 4x. Or you can also write as a plus bx exponent 4x. Both are acceptable. Whether you want to write this way also can, or this one also can. So this is second case. So the second case only occurred if b squared minus 4ac equal to 0. Okay, let's try one with initial condition. So this one. So we have d squared y over dx squared plus 4 dy dx plus 4y equal to 0. We are given two IVP. First one, y0 equal to 2. Second one, y prime 0 equal to 1. So you must differentiate the solution to get this second IVP. So transform into characteristic equation. So we have m squared plus 4m plus 4 equal to 0. Then by using a calculator, or you want to factorize this one, so you have m plus 2 m plus 2 equal to 0. So we have m equal to minus 2. So we have real and equal roots. So the solution will be y equal to a exponent minus 2x plus bx exponent minus 2x. Or you want to write as a plus bx exponent minus 2x. Either case is okay, yeah? Right. Then to substitute the initial value problem, you must differentiate the solution. So differentiate this one. So find y prime. So y prime, so we have a exponent minus 2x using chain rule. Multiplied differentiate exponent minus 2x, so you get minus 2. Here we have product rule. Bx times exponent minus 2x. So by using the product rule, bx exponent minus 2x minus 2 plus exponent minus 2x, differentiate bx, so you get b. So you have minus 2 exponent minus 2x minus 2 bx exponent minus 2x plus b exponent minus 2x minus 2a. Let's substitute the initial condition. So we are given two initial condition, y0 equal to 2 and y prime 0 equal to 1. Okay, by using the first equation, this one, so substitute x equal to 0, y equal to 2. So we have 2 equal to a exponent minus 2 times 0 plus b times 0 exponent minus 2 times 0. So we have 2 equal to a plus 0. So a is 2. So we have the first one, a equal to 2. Substitute second condition, y prime 0 equal to 1 into the second equation. So substitute into this equation. So we have 1 equal to
minus 2a. A is 2, so minus 2 times 2, exponent minus 2 times 0, minus 2b times 0, exponent 2 times 0, plus b exponent minus 2 times 0. F1 minus 4 plus b. So b equal to 1 plus 4. So we have a equal to 2, b equal to 5. Hence our solution will be 2 exponent minus 2x plus 5x exponent minus 2x. Alright, so this is our solution. Y equal to exponent minus 2x plus 5x exponent minus 2x. So this is for second case. Okay, next example. D squared y over dx squared plus 2 dy dx plus 4y equal to 0. So first thing first, as usual, transform into characteristic equation. So we have m squared plus 2m plus 4 equal to 0. Okay, by using quadratic formula or by using a calculator, so you can find the solution. Now let's say we want to use the quadratic formula. So y is equal to minus b plus minus b squared minus 4ac divided by 2a. So to find the solution for this one, you can use the calculator if you can, or you can factorize this one if you can, or if you cannot find by using factorization, try to use the quadratic formula. If your calculator can find a solution by using quadratic equation, why not you just use the calculator, kan lagi cepat. If you use your calculator, it will be much faster lah. And for this example, let's show how to find by using quadratic formula. So substitute into the equation. So this one is A, this one is B, this one is C. So we have minus 2, y equal to minus 2 plus minus 2 squared minus 4 times 1 times 4 divided by 2 times 1. So minus 2 plus minus 4 minus 16 minus 12. So from this one we can simplify it as 4 times root of 4 times minus 3 over 2. So minus 2 over 2 plus minus. So square root of 4 is 2 over 2 times square root of minus 3. So we have minus 1 plus minus. So this one can cancel out. Square root of 3 is square root of 3i ya. Ataupun square root 3 times square root minus 1. Square root minus 1 is I. So this one will be square root of 3i. So the solution for y, we have m1 equal to m1 and m2 equal to 1 minus 1 plus minus square root of 3i. So this is a complex root. So you have the case of complex root. So for complex root, identify alpha. So alpha is the real part. This is the real part. So alpha is minus 1. Beta is the imaginary part. So our imaginary part is square root 3. So write the solution. So the solution will be exponent alpha x a cos beta x plus b sine beta x. So exponent minus x a cos root 3x plus b sine root 3x. Okay, so this is our solution. And let's see another example. Okay, so we have d squared y over dx squared plus 25 equal to 0. This is a initial value problem, so you have two values for IVP. First is y0, second is y prime. So first thing first, transform by using characteristic equation. Transfer into characteristic equation. So we have m squared plus 25 equal to 0. And then we have m squared equal to minus 25. So m equal to, take the square root for minus 25. Square root minus 25. If you put in calculator square root minus 25, you will get error kan. Kalau masuk dalam calculator, you will get error because you cannot take square root negative 25. So this one you can write as square root of 25 multiplied minus 1. So this is square root 25 times square root minus 1. Square root 25 is 5. Square root 1 is I. So the answer is plus minus 5i. So from here, a real part, we don't have any real part. That means alpha equal to 0. Imaginary part is 5. Hence, our solution will be y exponent alpha x a cos 5x plus b sine 5x. Alpha is 0, sorry. Alpha is 0x. So alpha 0 is 1. So a cos 5x plus b sine 5x. Then to substitute the initial condition, you must have a y prime. So differentiate a cos 5x. So differentiate cos, you get minus sine 5x multiplied 5. Differentiate 5x, so you get 5 plus b. Differentiate sine, we get cos 5x. Differentiate 5, you get 5x. Differentiate 5x, you get 5. So minus 5a sine 5x plus 5b cos 5x. So this is y prime. Substitute the initial condition. So here initial condition y0 equal to minus 1. Y prime 0 equal to 3. So from the first one, so y0 equal to minus 1. So we have minus 1 a cos 5 times 0. So a cos 0 plus b sine 5 times 0. So sine 0. Cos 0 is 1. Sine 0 is 0. So we have minus 1 equal to a. So we have the first constant a. Yeah? Second, y prime 0 equal to 3 for second initial value. So substitute into this equation. So we have 3 equal to minus 5a times sine 0 plus 5b cos 5 times 0, 0. Sine 0. So sine 0 is 0. Cos 0 is 1. Sine 0 is 0. So we have 3 equal to 5b, hence b equal to 3 over 5. So the solution, substitute a and b into the solution here. A is minus 1, b is 3 over 5, so the solution will be minus cos 5x plus 3 over 5 sine 5x. So that is our solution. Alright, so we take 5. Please fill the attendance first. I will give you the link for the attendance in the you may find the link in the message. And then after this, we will do some exercise lah before we proceed with next chapter. Okay, we take 5 first.
Doctor, location. Doktor, location tu nak tulis apa, doktor?
Location to where you stay right now lah. Whether you at hostel or you at home. Okay, class. Okay, let's see this exercise. So this is exercise I take directly from the books. If you buying this book, you can refer to exercise 3. So I found that this is quite interesting question. So let's try to solve this one. Okay. For number 1, find the general solutions of y double prime minus 2a y prime plus a squared y equal to 0, with a is a non-zero constant. That means a is positive. A is a positive constant. Okay, I want you to try this one first. I will give you 3 minutes. Find question number 1. After that, we will discuss the solution for number 1. Okay, let's discuss the answer. Find the general solutions of y double prime minus 2ay prime plus a squared y equal to 0. So first, let's transform this one into a characteristic equation. So here we use y prime. So y prime is d squared y over dx squared. So you may use y prime or d squared y over dx squared. So y prime, or if we transform into characteristic equation, it will be m squared minus 2a m plus a squared equal to 0. Okay, now you have a quadratic equation. So in order to solve this quadratic equation, you cannot use the calculator, or you cannot mm, factorize this one in a factor form. So you must use the quadratic formula. So to use quadratic formula, m equal to minus b plus minus b squared minus 4ac divided by 2a. So here we have a, the coefficient, coefficient b, and the coefficient c. So from here we have minus b, so we have minus 2a plus minus roots of b squared. So we have minus 2a squared minus 4ac, c is a squared, divide by 2a, a is 1. So I have here minus minus 2a, so positive 2a, plus minus, so we have 4a squared minus 4a squared divided by 2. So here 4a squared minus 4a squared is 0, square root 0 is 0, so 2a divided by 2. So we have 2a divided by 2, or equal to a. So here we have only one root, so we have case real. We don't have any imaginary number, we don't have complex number, real and equal. So the type of root we have is real and equal root. So we have m1 also equal to m2, which is equal to a, not a number. We have a, a, this is non-negative number, so a is a positive number. So the solution will be a exponent ax plus bx exponent ax, or sometimes you like to write as a plus bx exponent ax. This way also can. So this is our solution. So far the attendant, we have 80 responses. 80 responses. I think not, I think 9 students are absent. So after this, I will close the attendance form. Please, if you don't fill the attendance form, please fill this attendance form. So many of you now at home. Shah Alam. Some of you still at campus. Maybe you didn't. Maybe you stay very far. Maybe at Sabah, Sarawak lah. So you didn't fly back to your home. Oh ada ni ya. Kota Marudu, Sabah pun ada. Dalam train ETS pun ada. Oh, boleh online lagi ya dalam train ETS. Kelantan, ramai juga Kelantan. Okay, let's see. Are you finished? Okay, let's see question number 2. solve the equation 2y double prime plus y prime minus 3y. 2y double prime plus y prime plus 3y. Let me write here. Equation number 2. We have 2y double prime plus y prime minus 3y equal to 0. So transform this equation into characteristic equation first. So we have 2m square plus m minus 3 equal to 0. And then find the roots of this equation. So find the m. So I want to use a calculator to solve this one. So I have m1 m1 equal to 1 and 2 equal to minus 3 over 2. So this is I directly take from my calculator. So this is real and this thing also. This thing. Hence the solution will be y equal to a exponent x plus b exponent minus 3 over 2 x. Question number 3. Determine the particular solution of the following differential equation. So we have d squared y over dx squared plus 14 dy over dx plus 49y equal to 0. So we are given y0 equal to 1, y prime 0 equal to minus 1. Okay, change into characteristic equation. So first we have m square plus 14m plus 49 equal to 0. Since I already have my calculator here, so let's plug in the values in the calculator. So we have m equal to minus 7. So we only have one values of m. So this is the case of real and equal roots. So the solution will be y equal to a exponent minus 7x plus bx exponent minus 7x. Okay, so substitute the initial value first. Before substitute, let's differentiate to get the y prime. So find y prime. So a exponent minus 7x multiplied minus 7 plus, here we have product of bx and 7x, so use product rule. Remember the differentiation by using product rule. So u du plus v dv, u dv plus v du, right? So here's some notes for you if you didn't remember. So u, which one is u? So this is u, this is v. So u bx, dv is exponent minus 7x times minus 7. So this is dv plus v du. So v is exponent minus 7x. Du is bx. So bx differentiate with respect to x. So you get b. So we have minus 7a exponent minus 7x plus minus 7bx. Sorry. Minus 7bx exponent minus 7x plus b exponent minus 7x. Let's substitute first initial condition. So we have y0 equal to 1. So from this equation, y0 equal to 1. So we have 1 equal to a exponent minus 7 times 0 plus b times 0 is 0. So we have a equal to 1. So I did not proceed with this one because I know substitute x equal to 0. So here will be 0. So we have here will be 1. So 1 equal to a. Then substitute second initial condition. Which one? Second, you say y double prime and y prime 0 is minus 1. So substitute into this equation. So we have minus 1 equal to minus 7a. A is 1. So minus 7 exponent minus 7 times 0 minus 7b exponent minus 7 times 0. Sorry, minus 7bx, right? Minus 7b times 0. So this one also 0 plus b exponent minus 7 times 0. So we have minus 1 equal to minus 7. Here will be 0. So plus b. So hence b equal to minus 1 plus 7. So b equal to 6. So the solution will be y equal to exponent minus 7x plus 6x exponent minus 7x. So this is the solution. Let Bob this solution. Okay, I will give you times to copy this one. If you want faster, you may screenshot terus snapshot, screenshot terus Okay, let's continue with question number 4. Let me write question number 4 above here. So what is our question number 4? This one. Determine the particular solution of the following differential equation. D squared y over dx squared minus 4 dy dx plus 9y equal to 0. So given two initial conditions, so we must solve in order to find the a and b. Okay, let's write the equation first. So d squared y over dx squared minus 4 dy over dx plus 9y equal to 0 given y0 0 y prime 0 equal to minus 3. Okay, first we transform this equation into characteristic equation. So here we have m squared minus 4m plus 9. So this one equal to 0. So by using a calculator, so substitute minus 4 and 9. So we have m equal to 2 plus minus root of 5i. So we have, this case we have complex root. Roots mean 2m's. S mean we have plus and minus. So we have m1 and m2. There are two roots. First 2 plus 5 root 5m. Second is 2 minus square root of 5i. So identify the real part. Real part will be alpha, which is 2. Identify beta. Beta is imaginary part, so root of 5. So the solution will be exponent alpha x a cos beta x plus b sine beta x. So we have exponent 2x a cos root 5x plus b sine root 5x. Okay, next substitute the initial condition. And before we substitute initial condition, we need to differentiate this one first in order to substitute the initial condition. So differentiate this one. So we can use the product rule. Once again, use the product rule. U dv plus v du. So first let expand this one. So expand this one. So we have exponent 2x multiply a cos 5x root 5x plus exponent 2x b sine root 5x. So for this part, you have exponent 2x a cos 5x. For this part, exponent 2x b sine 2 b sine 5x. So that means this is one product rule. This is also one product rule. So the answer, the calculation will be quite long. Okay, so first u, which is exponent 2x dv, we have a differentiate cos, you get minus sine. So minus sine 5x multiply root 5 plus a cos 5x multiply exponent 2x times 2. Differentiate exponent 2x, so you get exponent 2x times 2. So finish first part. Second part, I write in the below. So we have first u is exponent 2x, so u exponent 2x dv is b sine, we get cos 5x multiply 5 plus b sine 5x multiply exponent 2x times 2. Alright, so this is for y prime. Okay, now we are going to substitute the initial condition. So don't worry, you look it quite long, but don't worry because we only dealing with sine 0 or cos 0. So remember, sine 0 is 0, cos 0 is 1. So we are going to substitute our initial condition. So this is two initial condition, y0 equal to 0, y prime 0 minus 3. So let me write here. For y we have y0 is 0, so this is for the case y. So y0 is 0. So from here we have 0 equal to exponent 2 times 0. So I simplified 2 times 0 as 0. Cos a cos 5 times 0 cos 0 plus b sine 0. So here we have 0. Exponent 0 is 1. So a cos 0 is a. B sine 0, 0. So a is 0. Secondly, we have y prime 0 equal to minus 3. So we are going to use this one. This one. Let's box this one first. So y0 equal to minus 3. So let's write minus 3 equal to exponent. Alright, first thing is when I substitute sine 0 here, I get 0. So I can cancel this one. Here also I get 0. Sine 500. So this one is already cancelled out. So I have here a equal to 0, right? From this one, a equal to 0. Here I have a equal to 0. So this one also cancel. So now only this one. So we have minus 3 equal to exponent 2 times 0 is 1. No, sorry. Exponent 2 times 0. Exponent 0. B cos 50. So this is cos 0 times root of 5. So we have minus 3 equal to root 5, sorry, root 5b. So b is minus 3 over root 5. So y will be exponent alpha, exponent 2x, a is 0, so cancel out, b is minus 3 over 5 sine root 5x. Alright, this is our final answer. Okay, correct. I checked the answer. Correct. Eh? Square root 5. Sorry. Let me write like. Let me square root 5. Okay. So for this one, I will give you a few more exercise for you to practice. I know for online classes, sometimes you cannot be focused. So I will also give you the link for this Google meeting. We have recorded meeting. I have recorded this meeting, so I will give you the link later on. I think we will stop here because for the next subchapter, I need a few more time to explain to you. It's not enough in 30 minutes left. So we may stop here and continue on the Thursday. Next week, no class. Next week, you raya. Alright, that's all for me. Do you have any question? If you have any question, you just WhatsApp lah. Ask in the WhatsApp group lah. Okay, with that, I think that's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Thank you, sir.
Thank you, sir.
Selamat Hari Raya,
Thank you,
sir.
sir.
Thank you,
Selamat Hari
sir.
Raya.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sama.